This question is about circuits. It says that the diagram shows part of a lighting circuit in a house, and the circuit is protected by this fuse F. It asks to give two reasons why the lamps are wired in parallel. Now, parallel circuits, the current will split at each junction, as we can see here, and so that means that if we want, we can turn any one of these lamps on independently. And obviously you'd want that in a house because you wouldn't want to turn one light on and then the whole house's lights turn on, or turn one light off and the whole house's lights turn off. And what it also allows you to do is change how much brightness each room might get. And you might have a bigger room where you want to have a greater brightness, or you might have a small room where you want quite a dim lamp that will still light up the whole room. So the first thing I would say is that the lamps can work independently. And the second thing is that each room can get a different amount of power, and so the lamps can be different brightnesses. Then it asks us to work out what the current is at point P. Now, what we can see is that 0.26 amps went this way and 0.43 amps went this way. So all we've got to do to work out what it is do 0.26 plus 0.43. And that's going to give us an answer of 1.38, which is D. The next part of the question asks us to explain how a fuse protects the circuit. Now, a fuse is designed to melt when a certain amount of current flows through it. When a certain amount of current flows through a fuse, it's designed to be just the right thickness of wire to cause the fuse to melt, and then this will cut off the current to the main circuit, which will stop anything in the main circuit from overheating. And there's three things that we need to write down from that there. So I think I'm going to start with when the current exceeds the maximum value for the fuse melts, stopping the current. Then it asks us to state the equation linking power, current and voltage. And this is simply power equals current times voltage. And then we're asked to calculate the power of lamp L. That's this one here. So P equals current times voltage. The current running through lamp L is 0.26 amps. And because this is a parallel circuit, each one of these lamps is going to receive exactly the same voltage. And it tells us here that that is 230 volts. So we just pop that into the calculator and we get 60 watts. Then we're asked to calculate the amount of energy transferred to the lamp in 3 minutes and to give the unit. So energy is equal to power times time. So we've already worked out what the power is. Now we just need to convert the time into seconds. So we're going to have 60 watts, and then we're going to multiply it by 3 minutes, and then times it by 60 to get the seconds. And again, we put that all into the calculator, and we're going to get 11,000, and the unit for energy is joules. The next part of the question shows another circuit that you might see in a house. Now this time we've got two switches, which allow us to control this lamp from 2 different points. And often you'll have this in corridors or staircases in houses, so you can turn the lights on as you're about to go up the stairs, and then when you leave the staircase and you go into another room, you can turn the light off and you can save power. It asks us to complete the table putting a tick in the box to show if the lamp is lit, and a cross in the box if it is not lit. So this is switch 1 and this is switch 2. Here, if switch 1 is at W and switch 2 was at X, then that would mean the current would be able to come from the power supply, from S to W, across here, and then down from X to S, and then all the way through. So the lamp would be lit in this case. If it remained at W, but as shown in the diagram, it was in the Y position, then the current wouldn't be able to flow across this point here. So the lamp would not be lit. If this switch was changed to the Z position, and then this switch was changed to the X position, then again, the current wouldn't be able to move across both switches. So there would be no current flow at all. And then, if this switch was at point Z and this one was at point Y, then current would flow along this bottom branch here. So we would get current flowing through the circuit. Now, the last part of the circuit of the question is exactly what I was just talking about. Where would this be useful in a house? So, on a staircase or in a corridor.